Microservices Architecture with Simon Timms.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host. And make sure to check out www.azuredevops.show for the past episodes and show notes. And again, the goal of this podcast is to empower you and your teams with the information that you need so that you can move fast and deliver consistent quality using .NET and run your software systems with confidence in the Azure environment. And you can do it. Every single one of you listening can be software rock stars when you just use the right patterns and go in the right direction. So for the community, for those of you running .NET and Azure-related user groups, I've been doing a lot of online video presentations and continuing to do that, several on the schedule as well coming up. And if you run one of those user groups, I'd love to give a presentation for your group, and so reach out. Our sponsor, ClearMeasure, who makes this podcast happen, is a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results. And so if we can help, please get in touch. And if you are a .NET developer who'd like a path to become an architect, we are hiring. Just apply on the website, clearmeasure.com. And then finally, a lot of you are checking out the new podcast, Architect Tips. It is a video podcast, short targeted episodes. And remember that if you have a question that you'd like answered on that show, you can submit one via the website, architecttips.clearmeasure.com. You can find that in the various podcast directories. Now, our guest today, Simon Timms out of Calgary. He's an experienced principal software engineer with a demonstrated history of success working in a diverse range of industries. He's skilled in software as a service, .NET framework, continuous integration, C#, JavaScript, etc. He's interested in AI, DevOps, and microservices, Azure Functions. He is a more than a 5-time Microsoft MVP, and it's going to be a great show. So let's get on to it. Well, Simon Timms back again from episode 23. How are you, sir? Good to have you.
Oh, I'm great. It's nice to be here. Thanks for having me.
Oh, my pleasure. My pleasure. I can't believe it's been 2 years since we had you on the show, but a lot's happened since then, huh?
Yeah, usually we'd catch up at MVP summits or something like that, but everything's virtual nowadays, so good to do that.
Right. And I think you mentioned for the show it's still snowing in Calgary.
Oh, yeah, we've got months of snow left. It's really coming down at the moment, but it's been kind of an okay winter so far. We'll survive.
Awesome.
We're pretty used to it.
As long as it's predictable. Normal snow, not abnormal snow.
Yeah, it's still white. It's not blue or purple or anything like that. It's just standard snow.
Awesome. Well, you've been a Microsoft MVP for over 5, has lost count now. But
yeah, 6 years, maybe 7 years, something like that.
Yeah, you've done so much work with all kinds of different technologies, and you've written quite a bit on Azure Functions and done a lot of speaking there. But one we're focusing this show on is microservices. You've done so much work there, and my observation on the industry is that there's a lot of talk about microservices, but there's still the dust hasn't settled on best practices, what the heck it is, how you deal with it, how you run it in production, how you build, test, configure, deploy. What does a Visual Studio solution structure look like for a microservice? I mean, and if you're looking at a software system, how do you even make a decision? What level of decomposition and all those kinds of things. Mm-hmm. So let's talk about that, because you've done a ton of work in that space, and you could probably at least answer some of the questions for the listeners regarding that.
Sure, yeah, I'm happy to give it a shot.
So yeah, I set high expectations, right?
That's what I do.
Well, let's start at the beginning then. Just microservices. It's a word that people weren't really talking about much 10 years ago. There was the service-oriented architecture. And of course, you've always had system decomposition of just breaking a software system into components. But just give it a shot. What's the best definition? But then just in your own, in layman's terms, what the heck is it? And how is it different from just splitting up a system into multiple applications?
Right. So the definition that I throw around that I feel like sounds really cool is that it's a top-level software design which favors creating small, loosely connected services which maintain data autonomy. If it sounds like I'm just reading that off the slide that I have in the presentation, it's because it's exactly what I'm doing.
Busted.
Yeah. But the idea here is that this isn't something that you come up with at a low level. This is something you decide higher up inside your application, that this is going to be a microservices application, which means that you're going to break up the system into a bunch of individual components which are independently deployable. So you want to be able to say, okay, we're going to deploy a new version of the login service, and it's only going to be the login service that goes. And the idea is that it's supposed to maintain a degree of isolation from the rest of the system, because we don't want to change parts of the system that don't need to change. You don't want to be just constantly deploying these bits of the system or updating bits of the system when they don't really have any changes to. Basically, it comes down to that, like, if it ain't broke, don't fix it sort of thing. So sometimes you'll end up with services, and I've been on projects like this where we deploy a service right at the beginning of the project. Maybe it's responsible for sending email or something like that. And then we literally do not touch that project for 8 months, a year, 2 years, maybe, because it's working fine, it's doing exactly what we expect it to do. We have no concerns about it. So it's just a layer of abstraction there that means that we don't have to worry about breaking that service because it has well-defined contracts. It is going to be tested all the time. We might still run builds on it just to make sure that it's building still. We're just not going to deploy it. And we don't have to worry about it. Right. So otherwise, you have to think about like this whole big system as a whole. And when you deploy it, you're always running those risks of breaking stuff or changing things. But with microservices, we hopefully have proper barriers in place to stop that. And a lot of that is based on being able to just send messages back and forth between the services, well-known, well-defined messages.
Okay. So if I'm picking up on a few things just to try to say, okay, if you're going for a microservices architecture, what's in, what's out, when you say you don't touch that code for a while, if it's stable, then that would insinuate that a microservice has its own version control repository. Would that be true or false, or sometimes?
Yeah, I think that's probably a good definition to have, is that it's going to be, because it's independently deployable, we ideally want to look at having its own source control repository. Now, you can take that approach of saying, like, we're going to put all of our stuff in the same source control repository and then just have a bunch of rules that know which directories to build. So you can set that up. Like if you're doing something like Azure DevOps, you can set up a rule that says this particular build is only going to run if we make a change within this directory. But it's nice to have these things independent in their own repositories so that it makes that builds a little bit easier to split up. And it also means that you know exactly where to go to change that piece of code.
Okay, so in the technology world, when you say you can do it this way, it's possible to do it this way, well, then the response is, well, of course it is, because it's possible to do anything. But when it comes to all the tools just tend to work a certain way, and you make a decision, do you tend to have a microservice in its own version control repository, or do you tend to have many microservices in the same version control repository?
Yeah, that's something I've kind of flipped back and forth on a little bit over the years, but right now I'm into separate repositories for each service.
Okay.
And if there's stuff that needs to be shared between that, sometimes it's useful to share message definitions or that sort of thing, then that's something that can be shared, at least on the .NET side, with something like a NuGet package, and then the JavaScript side with an NPM package, and so on and so forth, with different repositories for different systems.
Well, so talk about that, because I think that's key. And I've had the same experience where even if you could put multiple services in the same version control repository, there's so much automation and DevOps tooling that just works better when it's separated. But now you have, let's just say, let's go for a simple application. You got a web application data store, and you've decided to take an offline batch job or an offline service and break it out and saying, this really needs to be independent. Now let's talk about shared dependencies. And what does that mean? Because, you might have started out before you decided to decompose things saying, oh, you know what, this offline job, whether it's an Azure function or just run as just any web job, or even in a container or a VM as a Windows service, who knows? You decide to break it out, but it queried let's keep it simple. It queried a table in the relational database that was used by the whole. So if you're going to say, oh, it's appropriate to now make this a microservice, what does that mean for that dependency? And what do you do about it?
Okay, so that comes down to the data autonomy part of microservices. That every microservice should have, if it needs to store data, it should have its own database. Now, you might have some microservices which are just stateless and they don't store any data at all. But you never want to have multiple microservices talking to the same database, because that is a very strong form of coupling between the microservices. And now it means that you get back into that old place where you want to make a change to a database table, but you don't know what else is using that database table, what other services, what other programs might be using it, so you can't make that. It's boxing you in. It removes your ability to iterate quickly. So with a microservice, you want to split that out, have a separate database. So if you need to have a service that has got storage to it, it owns that storage. It's the only one that changes it. And if other people need information from that, then they can either listen in on events that you raise, or they can send a request to you as a microservice to provide them that information. And then you're responsible for providing the kind of shimming layer in front of it that provides an abstraction of, like, this is the interface that I promise I will keep, but it still lets you make changes to the database schema under the covers. So if you discover that your database schema is terrible and you need to make some changes to denormalize tables, something like that, then you can do that without the fear of breaking other people who are using the service, because they're only using it through an abstraction, through an API.
Okay. All right. So that's another key. Are there any other tenets that you would say, if you're going to use microservices, then, like you mentioned, don't share dependencies, don't call a shared same database. Are there any other tenets that seem to be key?
I suppose the communication is a big one in there. So being able to communicate with your microservice is obviously an important factor. And there's a bunch of different ways of communicating between processes. So one of the ones that you'll see that was pretty big back in the service-oriented architecture days was that people would provide like a web interface, and then back then it probably would have been over SOAP, something like that they would send a request to another service and ask for some piece of data, and that data would be returned. Another possibility is to use messaging, where you're sending messages to services and raising events in services to inform other people about stuff that's changed. And I really like that approach a little bit better, because I think it provides user coupling, that you don't need to know about where other services are, or even who's interested in messages or events that happen inside the system. So it means that there's a really loose coupling. So let me give you an example here in some sort of like an order system. So we're making Amazon 2.0 here, which is the bigger, better Amazon.
Do it.
I'm sure we'll be very successful. So the idea here is that somebody's placing an order inside the system. So once the order is placed, we're going to raise an event inside of your system. Say, okay, an order has been raised here. But there are probably a lot of services out there, especially as the company grows, that are going to be interested in that information. So there might be people like the marketing department might be really interested to know when orders have been placed, because then they know who they can send subsequent marketing messages to. Shipping services might be interested, because then they can start the process of sending out orders for quotes to manage the shipping. But the order service, you don't want that to know about all those other people, because that provides really tight coupling. And when you have this coupling, it means that things are difficult to change. So when you raise an event, you're basically just saying, like, raising a flag to say, hey, there's an order. Anybody who's interested, pay attention to this. And all those other services are just sitting in their own little castles with binoculars, watching for these events to happen. When they happen, then they can start their own processes without being tightly coupled back into that original process.
As you're talking through some of those, I was kind of thinking about the alternatives and then the why, because these are a lot of things for people to think about. And some people may think, oh, I don't want to do that, which kind of pulls us back to, okay, well, we need to have a good reason for any architectural pattern that we use. So what are the dynamics, or what are the forces that cause us to say, you know what, microservices is going to work the best for this, while at the same time, microservices, it would absolutely suck if, another situation was true. Can you give a few examples?
Well, I mean, there's a myriad of places that have been very, very successful in deploying monolithic applications. So monolithic being kind of the opposite of microservices here, a single deployable code base. So for years, Facebook was very monolithic. GitHub is still pretty monolithic, although they're pushing a little bit more towards microservices now. But the problems that you end up with, or the places where microservices really shine, are if you have larger teams all working on the same code base. It's really nice to be able to put together kind of vertical teams within organizations and say, like, we've got 10 people on this team, and they're responsible for everything from writing the code to deploying the code to maintaining the code in production. That promotes a real sense of code ownership on teams. And it means that people are going to be writing better code, I think, in the long run, because ultimately, I don't want to be the person who's woken up at 4 a.m. because some service has stopped working. So I'm going to make sure that I write that service to be a little bit more robust and handle errors in a better way. Whereas if there was an entire DevOps team or something out there, an ops team out there who was responsible for running that service, I would probably be a little bit more willing to kind of throw them under the bus. So that's, I think, a really good place to use it. If you need to move quickly, I think that's another good place for microservices to be able to go out there and version individual services, get those pieces going pretty quickly. I think it's really good also for globally distributed teams because it allows you to create those kind of like pockets of developers that have independence. I mean, even though, and we've experienced this with COVID, right, that we're getting a lot better at managing to talk back and forth between different people around the world. It's still really nice to have kind of time zone co-location for teams. So you don't have to have meetings at 6 a.m. to talk to the team in India, and they don't have to stay at work until 6 p.m. to build their products out. So I think that's another really good place for it. Places that you have a lot of scalability concerns, another really good place, I think, for microservices, because it provides you the ability to tune different parts of the system up or down depending on the load. So I think of great things like a university. If you're registering for classes, there's like 2 times a year where there's a huge amount of load on that system. So you want to turn up that particular component in the system really high during that registration time. And then after that, the load falls off to almost nothing afterwards. So having that fine tunability knob is really nice for certain services.
Okay.
So those are kind of the big places that I think about using it.
Yeah, I think that's really interesting to place a lot of importance on the structure of the organization, the humans that are involved, so that they don't step on each other's feet and that there's not a lot of dependencies between the people versus just a purely technical argument or a runtime argument.
Yeah, well, this falls down to that sort of like Conway's law, that if you have 3 teams working on a compiler, you're going to end up with a 3-pass compiler. And then sort of ultimately you can change that around and pull what people call the reverse Conway maneuver, which is you change the structure of your software to reflect the way that you want your teams to appear. So by putting that kind of microservice pressure on this organization, you're going to end up with those small pockets of teams anyway. And if that's something that you're looking to have inside the organization, I think it's a really effective way to organize an organization, then microservices might be the way to go for that.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
Okay, well, there's tons of teams that have probably an application that has multiple deployed pieces, and they're probably, I've encountered some teams that say, oh, we use a microservices architecture, and then kind of look around and maybe they have several processes deployed as Azure Functions or web job, and they've got maybe maybe a public website and maybe a private or an employees only website. But at the same time, it's all one Visual Studio solution. Is that completely antithetical to microservices architecture, or is that just a flavor? Is it can the two coexist, or is that just no, that's not really microservices and this is why?
Yeah, I would tend to say that that's probably not microservices, because in that particular scenario, it sounds like everything's probably talking to the same database. So it violates sort of that autonomy of data. So what you have really is just like a bunch of views into the same data. So if you were doing microservices, you would probably have more like vertical partitioning of your application. Yeah, so you would take a silo of software functionality and you would move that off into a microservice. When teams are looking to move to microservices, one of the first things I look to do is to find a really easy victim. And often sending email is that really easy victim. So there's lots of places in the application where we're sending email. So what we're going to do is we're going to centralize that logic, and we're going to, instead of sending the email from the application, we're going to push that message onto a queue. And then this email service, which we've just stood up brand new, is going to be responsible for sending emails. So now all the email in the entire system goes through that piece of code. So if we have to change our email provider or something like that, then we know exactly where to go to make that change. And that's a really easy one because that doesn't tend to have any real persistence behind it. It's kind of an infrastructure service that you might split out. So that's kind of one kind of microservice vision that I look for is we're going to split out infrastructure functionality into its own service. And that's an easy one to do. The more difficult one is to figure out where your business domains fall into different pieces, and you can split those out as microservices. Because people are used to that all being kind of one big system. But if you look at a company, like any sizable company, they've got departments within the company that serve different roles. And within each one of those different departments, they're going to have different ideas about the data that is stored in the system. So this is getting into kind of the domain-driven design aspect of microservices. You don't have to do microservices domain-driven design, but they really dovetail well together. So if you think about that everybody's going to have a concept of a customer within the organization, but different people in the organization have a different concept of what a customer entails. The security people, a customer entails things like a bunch of PII data, a password, the locations that they've logged in from, so that you can check and make sure that people who typically log in from Detroit aren't all of a sudden logging in from Vladivostok. But that would be the idea of what a security group of people would think of as a customer, whereas a marketing department would also think of a customer, but their concept of a customer would be completely different. So they would think of things like what preferences they have, what sort of shopping history do they have over the years, those kinds of things. So that provides a different sort of splitting out. So within each one of those silos, you would end up building out a bunch of microservices within that domain and using that kind of shared definition of what a customer is to that group of people. So a domain-specific language in there. And then you would just split those out as different microservices. So going back to the example that was the start of this, where we've got a public and a private facing interface into this system, both of those could make use of different microservices, the same microservices within the organization, but just have a slightly different view of them. And that would make it more of a microservice-oriented architecture, I think, than just having a public and a private-facing website.
Mm-hmm. You mentioned message. You mentioned queue. There's also a lot of people that talk about web services. So these different services need to communicate with each other. What would cause you to choose one protocol, one type over another?
So what I've said in the past really is that anytime you're changing data within the system, you're much better to do that over messaging because you can treat that reliably. So if you need to update an address, then putting that into a message queue or raising an event within a messaging system is a much more reliable way of doing that than sending HTTP requests over like RESTful endpoints. So you can still use those HTTP requests, but that would tend to be in more of like a querying capacity. So if you're looking for data from another service, you can do it like that. And even that particular scenario, I'm kind of trying to steer people away from being able to go out and query other services for data. There's always going to be times where you need to know about data from other services. So as maybe a shipping service, I need to know about somebody's address. So if the address is changed, maybe I might not own that service. Maybe the billing service owns that address. But I can own a cache of that information. So when the billing service changes somebody's address, it's going to raise an event to say customer 123456's address is now this new address. So the billing service is going to raise that, and then the shipping service is going to pick up on that, as are maybe 10 or 12 other services, and they're going to update their local caches of that information. So it's not the canonical source of truth, and they can never be responsible for changing data within their cache. They're just looking for events to be raised by external systems that hint to them that they need to change their version in the cache. So I like that approach a little bit better. It is harder to implement, and you end up with like duplicates of a lot of data throughout the system, and you're relying on messaging to keep all of that consistent. So that's a real change from a traditional system where you're always looking towards the database to keep things consistent. Now you have to rely on the messaging system to be reliable, and also your reading of messages to be reliable as well, to actually be able to go and populate your cache with that information.
Okay. One of the common questions that I get is for people who've never done asynchronous queue-based messaging is, how should I do it? What are the patterns? Are there any tools or libraries? And I think there was a time, at least in the .NET space, that NServiceBus was, and then RabbitMQ or Mass Transit. It was like, okay, those were the best around. And today there are so many choices. They're still really great, but there's so many choices for that. You can get kind of lost. In your experience, is there kind of a go-to, if you were just to start up a new project today, is there, even without thinking, a go-to, or would that be a new evaluation because it's not to that point?
I think a lot of times I would have a go-to. So I deploy a lot of stuff out onto different clouds. So I deploy onto AWS and I deploy it onto Azure, and I'm aware of the existence of GCP, and I make fun of Oracle. So that's kind of like, I have kind of two top-tier clouds that I would end up deploying to. So on Azure, to me, the answer is pretty simple. There's basically two major messaging systems on Azure. There's a bunch more, obviously, but the real choice is between, do I use Azure Service Bus or do I use storage queues? And those two systems have vastly different properties to how they work. Like storage queues are literally just that. They are queues. So they don't have any support for pub sub or anything like that. They're one of the oldest, one of the cheapest, one of the most reliable systems on Azure. But I would probably steer people more towards Azure Service Bus these days on Azure. The Service Bus messaging is really good. It provides pub sub semantics. The APIs for it are a little bit confusing from time to time. So you might look at layering on top something like NServiceBus, which is going to provide that abstraction layer that gets you away from having to know the real nitty gritty of how Azure Service Bus works. On AWS, the solution in my mind is a little bit less clear. I counted, maybe a couple of months ago, I went out and counted how many messaging solutions there are native to AWS. I think I got to 15 before I gave up, because there's the simple messaging service, and that's probably the best known one. But then there's all sorts of stuff in like Kafka and in databases and things like that you can use as well. So on top of that, it's a little bit tricky as well. So again, I would push people towards something like NServiceBus. If you're looking to build out quickly, then having the ability to just build out to a single interface and not have to worry too much about the underlying protocols, it's really helpful from that point of view. And then the other approach, of course, in .NET is to take a look at something like mass transit, which is a very similar sort of system. So there's still a lot of really active development going on with mass transit. I actually just got off a call maybe an hour ago with Chris Patterson talking about the work that he's doing on mass transit, and it's really exciting, some of the durable futures stuff that's going on there. And then there's all this serverless approaches to stuff too. So Azure Functions is looking really interesting. They have a concept called durable functions, which are similar to the way that you would build out sagas in NServiceBus. They have durable, I want to call them durable entities. I'm not sure if that's quite the right term, which to me looks a little bit more like an actor pattern. So something like actor.net. So there is a ton of possibilities. I don't feel like I've answered your question very well. That yes, there's a million ways to do this, basically.
Well, I find it interesting. You talked about the cloud providers and the way to actually route the message in a durable fashion. But for Azure and Amazon, I took note that you mentioned NServiceBus for both. And so for I might translate that to, and you tell me if I'm wrong, for somebody who is totally new to this space and doesn't really understand how to evaluate what all the choices are, I heard you say that
yes.
for both.
Yeah.
And that would be a pretty good choice to start if you're just getting into the space.
Yeah, NServiceBus is really nice because it provides that abstraction layer over a bunch of different things. So over persistence, where you store your messages, over how you transport your messages, and it lets you swap in different versions. So, I mean, I often hear that question of like, now Azure Service Bus is so good, do we really need NServiceBus? Because the history of NServiceBus was that it was built out on top of MSMQ, which was a queuing system inside Windows, which has a huge history. Like, I think it came out in NT4 originally. And it's still around, although probably a little bit deprecated now. But the problem with MSMQ was that it had no pub-sub semantics. So NServiceBus was originally built out to kind of provide the pub-sub semantics on top of that. But it's since grown and changed to absorb a bunch of different transports and a bunch of different persistence layers. But it's helpful in that it kind of drives you down the same path. So it's removing some of these choices from you by being a little bit opinionated. And that can be really helpful. Like, we've seen how many different messaging services there are and how many different ways there are to do this. So sometimes, especially if you're just coming into a new project on this, saying, look, I'm just going to do it the way that a particular who make NServiceBus say that I should do it, then that's a really good approach. And it's going to remove a lot of that kind of tyranny of choice from you.
Well, our listeners appreciate opinionated people, because when you're learning something, you're trying to learn enough to formulate your own opinion. But the question is, okay, you've been doing this for a long time, Simon. What's your opinion? And that's valuable, right? So getting into that, we need some more strong opinionated approaches. You've got all these microservices now, and you've split the dependencies, and they're all factored properly. So now we have multiple version control repositories. Let me just some questions, true or false. So I have different version control repositories. That would mean, I think, tell me if I'm wrong, that each of those version control repositories has their own DevOps pipeline of builds, tests, packaging, deployments, correct? Or how would you flavor your thinking on that?
Yeah, absolutely. I would have each one of them kind of responsible for their own deployments, responsible for their own pipelines, sometimes even responsible for their own operations, so their own scaling, their own infrastructure provisioning.
Okay. So now we can, independently build, test, we independently deploy, totally different schedules and windows there. Now we're all in production, and I need to figure out, what is my whole system doing? There's all these products that work great for a single application. Is there a product or a method that works great when you have half a dozen or a dozen of these independent now programs running around doing stuff?
Yeah, absolutely. So one of the key things you should look for is the ability to assign correlation IDs to messages, because that'll give you an idea of how a message is flowing through your system. So if I start off with that same idea of putting in an order, that order is going to have a special ID attached to it called a correlation ID. And then every event that is driven or created as a result of that order, be it like the order has shipped, something's been fulfilled, something with those lines, they're also going to have that correlation ID on them. And then in .NET, at least, you can raise those as part of the .NET instrumentation. And that's going to go into something like App Insights. And within App Insights, you'll be able to draw out the map of, hey, these are all the services. This is how they interact. This is the correlation ID as messages move throughout the system. So that's really useful to have, to be able to draw that map out and to be able to see, like, hey, this message started over here and it's going to flow through the system and end up down here doing something completely different. And on the way, it's encountered these 3 exceptions, and we've had to do the following compensating actions to handle for those exceptions. So having that really high-level view is super useful, I agree. So App Insights is a tool that I talk about related to that. I'm sure that other kind of infrastructure monitoring tools and logging tools like Datadog are going to have that ability too. I really like Application Insights. I steer people there, even people who are on AWS. CloudWatch in AWS is sort of their equivalent service, and it is very immature compared with Application Insights. So I have deployed stuff out to AWS that actually sends its telemetry back into Azure so that we can get a better view of how the system's working.
Yeah, man, if you have multiple programs running around, just using the generic term programs, or what other, and you don't have insight into what they're doing and how they're all working together, well, that's a recipe for chaos.
Yeah, well, I think probably you're going to hit a certain scale where you can't do that anymore. Like, I don't know how Amazon work internally, or Netflix is another big proponent of microservices. I think that there are enough microservices within their system that you couldn't intelligently trace a message throughout the entire system, because there's just no way that any one person could understand that. And that's okay. That's one of the advantages of microservices, is that you don't have to have the entire system in your mind to debug it. Mm-hmm. You're really looking for, how is this one part of the system that's bounded just in this little area? How is that interacting?
Yeah. Good point. Well, wow. We have covered a lot in a short period of time. I feel like we could do a whole two or three more shows on this, but I appreciate you giving the high points, because there's still a lot of people who see that microservices might simplify their challenge, but they're asking the question, okay, what do I change? How do I get started? So if they want to kind of dig in further, are there any go-to resources or books or text or video that you're aware of that kind of help those people?
Boy, there's certainly a few reasonable books out there, none of which I can remember at the moment, but maybe I'll drop you a list afterwards and you can go in the show notes. In terms of sites or people to look at, certainly the NServiceBus documentation is good. There's some good documentation, I think, on Microsoft's learning sites to go through and figure out how to build these microservices. But the key problem with microservices, and one of the reasons why it's so poorly defined, I think, is that it's going to vary depending on your situation. So the way that you build microservices is going to end up being different from the way that anybody else builds it. And that's okay. So it's fine to build out your own view of this thing. And I think what you can look for in the books and documentations out there is really just some guidance and some gotchas of people who've done it before. Certainly look to companies that have done it. Netflix have great technical blogs out on how they do it. The Azure DevOps team have been through an operation inside of their organization, splitting their stuff up to microservices. And then I think probably the GitHub blog is going to be one to watch in the coming years as they push further and further into breaking up their monolith.
Mm-hmm. Mm-hmm. Yeah. All right. Good stuff. Well, Simon, hey, thanks for coming back on the show. This is a great talk. Absolutely. All righty. Well, dear listener, until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.